June 6, 1944. D-Day. While thousands of Allied soldiers stormed the beaches of Normandy, while bullets tore through the air and shells exploded across the sand, another invasion was quietly beginning. One that no German soldier would ever see. One that would never fire a shot. But without it, the entire Allied advance across Europe would grind to a halt within weeks. Beneath the waves of the English Channel, engineers were preparing to lay something impossible. A pipeline. Not just any pipeline. A flexible steel tube that would stretch 70 miles across one of the most treacherous bodies of water in the world. It would pump fuel. Millions of gallons of it. From the shores of England to the beaches of France. And it had to work. Because tanks don't run on courage. Planes don't fly on hope. And without fuel, the greatest military operation in history would become the greatest failure. They called it Operation Pluto. Pipeline under the ocean. It was so secret that even most Allied commanders didn't know it existed. So ambitious that engineers said it couldn't be done. So vital that without it, the war might have been lost. This is the story of the men who built the impossible. The pipeline that changed everything. And the fuel that won the war. The problem no one wanted to talk about. 3 months before D-Day. Inside a cramped office in London, a group of military planners sat around a table covered in maps, charts, and cigarette ash. The mood was tense. They were planning the largest amphibious invasion in history. But there was a problem. A massive, unavoidable problem that threatened to derail everything. Fuel. General Dwight D. Eisenhower, Supreme Commander of the Allied forces, had made it clear. Once the invasion began, the advance couldn't stop. The momentum had to be relentless. Push the Germans back, liberate France, drive toward Berlin. But momentum required fuel. Tanks, trucks, jeeps, aircraft, landing craft, everything ran on petroleum, and the numbers were staggering. A single Sherman tank consumed roughly 1 gallon of fuel per mile. A single infantry division required 50,000 gallons per day. By conservative estimates, the Allied forces would need over 1 million gallons of fuel every single day once the invasion was underway. And that was just to maintain operations. To advance, they'd need even more. The traditional method was simple. Load fuel into drums, stack the drums onto ships, sail the ships across the channel, unload the drums onto the beaches, transport them inland. It worked. But it was slow, dangerous, and inefficient. German U-boats prowled the channel. Luftwaffe bombers targeted supply ships. Storms could delay deliveries for days, and every drum had to be handled manually, loaded, unloaded, moved, stored. It was a logistical nightmare. Worse, the beaches themselves were chaos. Thousands of men, hundreds of vehicles, mountains of equipment. Adding fuel drums to that mess would clog the entire operation. And if the fuel didn't arrive on time, the tanks would stop, the trucks would stall, the planes would be grounded, and the Germans would counterattack. One officer put it bluntly. "We can land 1 million men on those beaches, but if we can't fuel them, they'll be sitting ducks." The room fell silent. Everyone knew he was right, but no one had a solution. Then someone spoke up. A quiet voice from the back of the room. "What if we didn't use ships at all?" The room turned. The speaker was a civilian, a petroleum engineer named Arthur Hartley. He had been brought in as a consultant. Most of the officers barely knew his name. But what he said next would change the course of the war. What if we laid a pipeline directly across the channel, from England to France, pump the fuel underwater, no ships, no drums, just a continuous flow. There was a long pause. Then someone laughed. "You're joking." Hartley didn't smile. "I'm not." Another officer shook his head. "The channel is 70 miles wide. The currents are brutal. The depth varies wildly. And you want to lay a pipeline across it? Impossible." Hartley leaned forward. "Difficult, not impossible. We've laid pipelines across rivers, across lakes. This is just bigger." "Bigger," someone scoffed. "It's the English Channel, in the middle of a war, with German patrols everywhere. You'd need miles of pipe, specialized ships, months of construction. And even if you managed to lay it, what's to stop the Germans from blowing it up?" Hartley didn't flinch. "We make it flexible. We bury it on the seabed. We disguise the operation. And we do it fast, before they even know it's there." The room erupted in debate. Some called it genius. Others called it madness. But one man stayed quiet. Admiral Louis Mountbatten, Chief of Combined Operations. He had been listening carefully, and when the room finally settled, he spoke. "How long would it take?" Hartley met his eyes. 6 months, maybe less, if we start now." Mountbatten nodded slowly. "Then we start now." And just like that, Operation Pluto was born. Not with fanfare, not with certainty, but with a desperate gamble that the impossible could be done. Because in war, sometimes the only way forward is to build a road no one believes exists. The engineers who said yes. Arthur Hartley wasn't a soldier. He was a petroleum engineer from Birmingham. Before the war, he had worked for Anglo-Iranian Oil Company, designing pipelines across the deserts of the Middle East. He understood pressure, flow rates, material stress. But he had never built anything like this. When Mountbatten gave the green light, Hartley assembled a team. Not from the military, from industry. He recruited pipeline engineers, welders, metallurgists, men who understood steel and stress and the physics of fluid dynamics. Men who didn't care about rank or protocol. They cared about solving problems. One of the first was Bernard Ellis, a mechanical engineer from Manchester. Ellis had designed flexible hoses for oil tankers. He understood how to make steel bend without breaking. Another was Geoffrey Lloyd, a chemist who specialized in corrosion resistance. He knew how salt water could destroy metal in months. And then there was Connolly, a naval architect who had designed submarine cables. He understood how to lay heavy objects on the ocean floor without them shifting or breaking. Together, they formed the core of the Pluto team. And their first task was simple. Figure out how to build a pipeline that could survive the English Channel. The challenges were immense. The channel wasn't just wide, it was violent. Tides could shift by 20 feet. Currents could reach 5 knots. The seabed was uneven, rocky in some places, sandy in others. And the water was cold. Cold enough to make steel brittle. Traditional pipelines were rigid, made of welded steel sections, but a rigid pipe would snap under the stress of the channel's currents. So they needed something flexible, something that could bend and twist without breaking. But flexible steel didn't exist, not in the quantities they needed, not in the time they had. Ellis proposed a solution, a lead core pipeline. Lead was soft, malleable. It could be extruded into long, continuous tubes, and it could be reinforced with steel wire to prevent collapse. The result would be a pipeline that was both flexible and strong. But it had never been done before, not at this scale. They built a prototype, a 100-foot section of a lead pipe, reinforced with steel wire, coated in protective layers. They tested it in a tank, bent it, twisted it, subjected it to pressure. It held. But would it hold under 70 miles of ocean? No one knew. Lloyd tackled the corrosion problem. Saltwater was the enemy. It would eat through steel in months. So he developed a protective coating, a mixture of tar, rubber, and chemical sealants. It wasn't perfect, but it would buy them time. Enough time, he hoped, to win the war. Connolly designed the laying mechanism. They couldn't just drop the pipeline into the water. It had to be laid carefully, slowly, without kinks or breaks. He proposed using modified cable-laying ships, ships that had been used to lay telegraph cables across the Atlantic. They had massive drums that could hold miles of cable, and they had the precision to lay it on the seabed without damaging it. But there was another problem. The pipeline had to be continuous. No joints, no welds, because every joint was a potential failure point, and a failure 30 miles out to sea would be catastrophic. So they needed to manufacture the pipeline in continuous lengths, miles of it, and they needed to do it in secret. The British government requisitioned a factory in Tilbury, on the Thames estuary. It was converted into a pipeline production facility. Workers operated around the clock, extruding lead, wrapping steel wire, applying protective coatings. The factory produced over 70 miles of pipeline in less than 4 months. It was an industrial miracle. But the pipeline was only half the problem. They also needed pumping stations, massive pumps that could push fuel through 70 miles of pipe, against the resistance of the water, against the friction of the pipe itself. The pumps had to be powerful, reliable, and hidden. They built them on the English coast, disguised as ordinary buildings, barns, warehouses, even fake cottages. Inside, massive diesel engines drove centrifugal pumps capable of moving thousands of gallons per hour. The noise was deafening, but from the outside, they looked like nothing. By May 1944, everything was ready. The pipeline, the pumps, the ships, the plan. But no one knew if it would work, because no one had ever done anything like this before. And if it failed, the invasion would fail with it. Hartley stood on the deck of a cable-laying ship, watching the first section of pipeline being loaded onto the massive drum. The steel wire glinted in the pale morning light. The lead core was dark, almost black. It looked fragile, impossibly thin for the task ahead. Someone asked him, "Do you think it'll hold?" Hartley didn't answer right away. He just stared at the pipeline. Then he said quietly, "It has to. Because in war, hope isn't enough. But sometimes it's all you have." The 2 types of pipe. What made Operation Pluto even more remarkable was that the engineers didn't develop just one type of pipeline. They developed 2, each with its own strengths, each designed for different conditions, and both were revolutionary. The first was called Hamel, named after the Anglo-Iranian oil company's chief engineer, H.A. Hammock, and the lead engineer, B.J. Ellis. Hamel pipe was made of lead, 3 inches in diameter, reinforced with steel wire wrapped in a spiral pattern. The entire assembly was then coated in protective layers of jute, bitumen, and more steel wire. The result was a pipe that was flexible enough to coil onto a drum, yet strong enough to withstand the pressure of pumping fuel across 70 miles of ocean. Each length of Hamel pipe was continuous. No joints, no welds. It was manufactured in a single, unbroken strand that could stretch for miles. The lead was extruded through massive dies at the Tilbury factory. Then it passed through a series of machines that wrapped it in steel wire, applied the protective coatings, and coiled it onto enormous drums. The drums themselves were engineering marvels, 40 feet in diameter. capable of holding 30 miles of pipeline, mounted on ships specially modified to carry them. But Hamel had limitations. It was relatively narrow, only 3 inches in diameter. That limited the flow rate. And it was heavy, very heavy. Each mile of Hamel pipe weighed over 30 tons. That made it difficult to handle, difficult to lay, and difficult to recover if something went wrong. So the engineers developed a second type, HAIS, named after Hartley, Anglo-Iranian, and Siemens Brothers, the cable manufacturing company that helped produce it. HAIS pipe was different. Instead of lead, it used steel, but not rigid steel, flexible steel. The pipe was made of interlocking steel strips, wound in a spiral pattern, like a giant spring. This gave it flexibility while maintaining strength. HI's pipe was wider than Hamel, 4 inches in diameter. That meant it could carry more fuel, but it was also more complex to manufacture. The steel strips had to be precisely machined. The spiral winding had to be perfect. Any imperfection could cause the pipe to fail under pressure, and like Hamel, it had to be coated with protective layers to resist corrosion. The 2 types of pipe were used in different locations. Hamel was used for the shorter crossings, from Dungeness to Boulogne, from Shanklin to Cherbourg. Chauvis was used for longer runs, and for sections where higher flow rates were needed. But both types faced the same challenge. They had to be laid on the seabed, in the middle of a war, under the noses of the German Navy. And they had to work. Because if they didn't, the entire operation would fail. The testing phase was grueling. Engineers subjected the pipes to every conceivable stress. They bent them, twisted them, froze them, heated them, subjected them to pressure far beyond what they would face in actual use. They dragged sections across rocky ground to simulate the seabed. They left them submerged in salt water for weeks to test corrosion resistance. And they failed, again and again. The early prototypes leaked, the protective coatings cracked, the steel wire corroded, the lead developed stress fractures. Each failure was analyzed, each problem was solved, and slowly, painfully, the pipes improved. By the spring of 1944, both Hamel and Heiss pipes were ready. They had been tested, refined, perfected. But the real test was still to come. The English Channel. 70 miles of cold, turbulent water, strong currents, rocky seabed, and German patrols. The engineers knew that even with all their testing, there were no guarantees. The channel was unpredictable. Conditions could change in minutes. A storm could tear the pipeline apart. A German mine could destroy it. A U-boat could target the laying ships. But they had done everything they could. The pipes were as good as they could make them. The ships were ready. The pumps were installed. And the invasion was coming. Ready or not, Operation Pluto was about to begin. And in the quiet moments before the first pipeline was laid, the engineers allowed themselves a moment of doubt. What if it didn't work? What if the pipes failed? What if all their effort, all their innovation, all their hope came to nothing? But then they remembered why they were doing this. The soldiers on the beaches, the pilots in the skies, the sailors on the seas, all of them depended on fuel, and if the engineers didn't provide it, those men would die. So they pushed the doubt aside. They checked the pipes one more time. They reviewed the plans. They prepared the ships. And they waited for the order to begin. Because in war, there's no room for doubt, only action, only determination, only the belief that what needs to be done can be done, and will be done. The secret construction. spring of 1944. While the world watched the skies and the seas, waiting for the invasion everyone knew was coming, a different kind of preparation was underway. Hidden, silent, invisible to all but a select few. Along the southern coast of England, in the towns of Dungeness and Shanklin on the Isle of Wight, construction crews worked day and night. But they weren't building barracks or airfields. They were building something far stranger. Massive concrete structures, pump houses, storage tanks, and enormous steel drums 40 feet in diameter, mounted on rotating platforms. To the locals, it looked like some kind of industrial project, maybe a new power station, maybe a water treatment facility. No one asked too many questions. In wartime Britain, secrecy was a way of life. But the truth was far more extraordinary. These were the terminals for Operation Pluto, the starting points for the undersea pipelines that would fuel the invasion. And everything about them had to remain secret. Because if the Germans discovered what the Allies were planning, they would do everything in their power to stop it. Security was extreme. The sites were surrounded by barbed wire. Guards patrolled 24 hours a day. Workers were vetted, backgrounds checked, and they were told nothing beyond their specific task. Welders welded, electricians wired, engineers supervised. But no one knew the full picture. No one except the core Pluto team. The pipeline itself was manufactured in sections at the Tilbury factory. Each section was over a mile long, coiled onto massive drums like thread on a spool. The drums were then transported by rail to the coastal terminals, under cover of darkness, covered with tarps, guarded by armed soldiers. The ships that would lay the pipeline were equally secretive. They were converted cable-laying vessels, HMS Holdfast, HMS Latimer, and several others. They had been used before the war to lay telegraph cables across the Atlantic. Now they were being repurposed for a far more dangerous mission. The ships were modified extensively. The cable drums were replaced with larger drums capable of holding the heavier, thicker pipeline. The laying mechanisms were reinforced, and the ships were equipped with specialized navigation equipment, because laying a pipeline across the channel required precision. A deviation of even a few hundred yards could mean disaster. The crews were hand-picked, experienced sailors, engineers, divers, men who understood the sea, who could work under pressure, who could keep a secret. They were briefed in stages. First, they were told they would be laying cables. Then, closer to D-Day, they were told the truth. They would be laying fuel pipelines. Across the channel, under enemy fire, if necessary. The reaction was mixed. Some were excited, others were terrified. But all of them understood the stakes. If they failed, the invasion would run out of fuel, and the war would be lost. Testing began in April. A short section of pipeline was laid across the Solent, the strait between the Isle of Wight and the mainland. It was only a few miles, but it was enough to test the system, the laying mechanism, the pumps, the flow rates. The first test was a disaster. The pipeline kinked. The protective coating cracked. Salt water seeped in. Within hours, the pipe began to corrode. The engineers were devastated. Months of work, millions of pounds. And it didn't work. But Hartley didn't give up. He analyzed the failure. The kink had occurred because the pipe was laid too quickly. The tension was too high. So they slowed down. They adjusted the laying mechanism. They added rollers to guide the pipe more gently into the water. The second test was better. The pipe laid smoothly. No kinks, no cracks. But the flow rate was too low. The pumps couldn't push the fuel fast enough. The friction inside the pipe was greater than they had calculated. So they increased the pump pressure. They widened the pipe diameter slightly. They smoothed the interior surface to reduce resistance. The third test worked. The pipeline laid perfectly. The pumps pushed fuel at the required rate, and the pipe held for days, then weeks. It was a success, but there was no time to celebrate. D-Day was less than 2 months away, and they still had to lay 70 miles of pipeline across the English Channel, in secret, under the noses of the German Navy. The plan was audacious. The pipelines would be laid in stages. The first stage would begin immediately after D-Day, once the beaches were secured, once the Allies had a foothold in France. The ships would sail from England, trailing the pipeline behind them like a massive umbilical cord. They would lay it on the seabed, bury it where possible, and connect it to temporary terminals on the French coast. But there was a problem. The Germans. They controlled the channel. Their patrol boats, their submarines, their aircraft. If they spotted the pipeline ships, they would attack. And the ships were slow, vulnerable, loaded with miles of pipeline and thousands of gallons of fuel. A single torpedo could destroy everything. So the Allies devised a cover story. The ships would be disguised as minesweepers or cable repair vessels. They would sail in convoys, protected by destroyers, and they would lay the pipeline at night, under cover of darkness, when German patrols were less active. It was risky, dangerous, but it was the only way. And as the days counted down to D-Day, the Pluto team worked around the clock, preparing, testing, praying that when the moment came, everything would work. Because if it didn't, the greatest invasion in history would become the greatest failure, and the men who built the impossible would be remembered as the men who tried and failed. But failure wasn't an option, not for Hartley, not for his team, not for the thousands of soldiers who would depend on the fuel flowing through that pipeline. So they worked, and they hoped, and they waited for the order to begin. D-Day and the first crossing, June 6, 1944. The world held its breath. On the beaches of Normandy, Allied soldiers fought and died. In the skies above, aircraft roared. On the seas, warships pounded German defenses. It was chaos. It was hell. But it was also the beginning of the end. And 70 miles away, on the southern coast of England, the Pluto team watched and waited. They couldn't begin yet. The beaches had to be secured first. The Germans had to be pushed back. A foothold had to be established. Only then could the pipeline be laid. For 3 days, they waited, monitoring reports from Normandy, tracking the progress of the invasion. Every hour felt like a lifetime, because they knew that every hour without fuel was an hour closer to disaster. On June 9th, the order came. Begin laying the pipeline. The beaches were secure, the Allies had a foothold, and the fuel was needed, desperately. HMS Holdfast was the first ship to sail. It left Dungeness at dawn, escorted by 2 destroyers. The massive drum on its deck held over 30 miles of pipeline, coiled tight, ready to be laid. The crew was tense, silent. They knew the risks. German U-boats, mines, aircraft. Any one of them could end the mission before it began. The channel was rough that morning. Waves crashed over the bow. The ship rolled and pitched. But the captain held course, straight toward France, toward the beaches where men were still fighting, toward the future of the war. The laying mechanism was activated 10 miles from the English coast. The pipeline began to uncoil from the drum, slowly, carefully, guided by rollers and pulleys. It slid over the stern of the ship and into the water. The lead core glinted briefly in the sunlight. Then it disappeared beneath the waves. The ship moved at 3 knots, slow, steady. The pipeline trailed behind like a dark ribbon, sinking to the seabed. The engineers monitored every inch, watching for kinks, for breaks, for any sign of failure. But the pipeline held. Mile after mile, it held. The tension on board was unbearable. Every man knew that at any moment disaster could strike. A German patrol could appear. A mine could detonate. The pipeline could snap. And if any of those things happened, months of work would be lost, and the invasion would be in jeopardy. But the hours passed, and the pipeline kept feeding out, smooth, steady, unbroken. The engineers began to allow themselves a glimmer of hope. Maybe, just maybe, this would work. Halfway across, a German patrol plane appeared, high above, circling. The destroyers immediately moved to shield the holdfast. Their anti-aircraft guns tracked the plane, but it didn't attack. It just circled, watching. Then it flew away. The crew exhaled, but the tension remained, because they knew the Germans had seen them, and they would be back. But the Germans didn't come back, not that day. Maybe they thought the holdfast was just another minesweeper. Maybe they had bigger targets, or maybe they simply didn't understand what they were seeing. Whatever the reason, the holdfast was left alone. And the pipeline continued to unspool. By nightfall, the holdfast reached the French coast. The pipeline had been laid, 30 miles of it, resting on the seabed, invisible, silent. But there. The ship anchored offshore, and engineers went ashore to connect the pipeline to a temporary terminal, a pumping station hastily constructed behind the beaches. The connection was made, the pumps were activated, and for the first time, fuel began to flow. From England, under the Channel, into France. It was a trickle at first, a few hundred gallons per hour. But it was flowing. The impossible had been done. Back in England, Hartley received the message. Pipeline operational, fuel flowing. He didn't celebrate. He just nodded. Because one pipeline wasn't enough. They needed more. Many more. To supply the entire Allied advance. Over the next 3 months, more pipelines were laid. From Dungeness to Boulogne. From Shanklin to Cherbourg. Each one a separate operation, each one fraught with danger. German attacks increased. U-boats targeted the pipeline ships. Aircraft bombed the terminals. But the pipelines kept being laid, and the fuel kept flowing. By August, there were 17 pipelines operational, stretching across the channel like invisible veins, pumping over 1 million gallons of fuel per day. Enough to supply entire armies, enough to keep the tanks rolling, the trucks moving, the planes flying. The Germans never fully understood what was happening. They knew the Allies were getting fuel, but they assumed it was coming by ship. They targeted supply convoys, bombed ports. But the pipelines remained hidden, buried on the seabed, protected by the very water that made them seem impossible. And as the Allies pushed deeper into France, as they liberated Paris, as they drove toward Germany, the fuel kept flowing. Silently, invisibly, the lifeline that no one saw, but everyone depended on. Operation Pluto had succeeded, not with a bang, but with a steady, relentless flow. The impossible had become reality. And the war would never be the same. The hidden heroes. Behind every great operation are the people no one remembers. The ones who didn't storm beaches or fly missions. The ones who worked in the shadows, who solved problems no one else could solve, who made the impossible possible. For Operation Pluto, those people were the engineers, the welders, the divers, the pump operators, the sailors, men and women who worked around the clock, in secret, under pressure, with no recognition, no medals, no parades. Take George Mitchell, a welder from Glasgow. He spent 6 months in the Tilbury factory, welding steel, reinforcement onto lead pipes. His hands were scarred from burns, his lungs filled with fumes, but he never complained, because he knew what he was building mattered, even if he didn't know exactly how. Mitchell worked 12-hour shifts, sometimes longer. The factory never stopped. Day and night the machines ran, extruding lead, wrapping wire, applying coatings. And Mitchell was there, welding, checking, making sure every joint was perfect, every seam was tight, because he knew that a single weak point could doom the entire pipeline. He never saw the finished product, never saw the pipelines laid across the channel, never knew how many lives his work saved. He just did his job, day after day, week after week, until the war ended and he went home to Glasgow, back to his family, back to his life, with nothing but scarred hands and the quiet knowledge that he had been part of something important. Or Mary Thornton, a chemist who worked with Geoffrey Lloyd. She tested corrosion resistance, mixing compounds, running experiments, working 16-hour days. She was one of the few women on the Pluto team, and she faced skepticism, doubt. But her work was critical. The protective coating she helped develop kept the pipelines intact for years. Thornton had studied chemistry at Cambridge before the war. She was brilliant, meticulous, and determined. When Lloyd recruited her for the Pluto project, she jumped at the chance, not for glory, not for recognition, but because she wanted to contribute, to make a difference. She spent months testing different compounds, mixing tar and rubber and chemical sealants, subjecting samples to salt water, to pressure, to temperature extremes. Most of her experiments failed, but she kept trying, kept refining, until she found a formula that worked, a coating that could protect the pipeline from the corrosive effects of the sea. Her work was never acknowledged publicly. Her name never appeared in reports. But without her, the pipelines would have corroded within months, and the fuel would have stopped flowing. She saved the operation, and she did it in silence. Then there were the divers, men like Thomas Riley, a former commercial diver from Liverpool. He was tasked with inspecting the pipelines after they were laid, diving in the cold, dark waters of the channel, checking for damage, for leaks, for any sign of failure. It was dangerous work. The currents were strong, visibility was near zero, and German mines still littered the seabed. But Riley dove, again and again, because the pipelines had to be checked, and someone had to do it. Riley made over 50 dives during the operation. Each one was a risk. Each one could have been his last. The water was so cold it numbed his fingers within minutes. The currents were so strong they could sweep him away if he lost his grip. And the darkness was absolute. He worked by feel, by instinct, checking every inch of pipeline he could reach. Once he found a crack, a small fracture in the protective coating. Salt water was seeping in. If left unchecked, the pipeline would fail within days. Riley marked the location, surfaced, reported the problem, and engineers repaired it. The pipeline kept flowing, and Riley went back down, because there were more pipelines to check, more dives to make. He never talked about his work, never sought recognition. After the war, he went back to commercial diving, working on oil rigs in the North Sea. He died in 1978, and his obituary made no mention of Operation Pluto. But the men who worked with him knew. They knew what he had done, and they never forgot. The pump operators were equally vital. Men like Harold Simmons. He operated one of the main pumping stations at Dungeness. His job was to keep the fuel flowing, 24 hours a day, 7 days a week. The pumps were massive, loud, temperamental. They broke down constantly, and when they did, Simmons fixed them, in the middle of the night, in the rain, under blackout conditions, because if the pumps stopped, the fuel stopped, and if the fuel stopped, the war stopped. Simmons was a mechanic before the war. He understood engines, understood how things worked. When he was recruited for Pluto, he was told only that he would be operating pumps. He wasn't told what they were pumping or where it was going. He just did his job. The pumps ran constantly. The noise was deafening, the heat was oppressive, and the pressure was immense. Simmons monitored gauges, adjusted valves, listened for any sound that indicated a problem, and when something went wrong, he fixed it. Fast. Once, a bearing seized in the middle of the night. The pump began to overheat. If it failed, the fuel supply to an entire army would be cut off. Simmons shut down the pump, disassembled it, replaced the bearing, and got it running again, all in under 3 hours. The fuel never stopped flowing, and no one on the front lines ever knew how close they had come to disaster. These men and women never made the history books. Their names aren't on monuments. But without them, Operation Pluto would have failed, and the Allied advance would have stalled. There were also the sailors, the crews of the pipeline-laying ships, men like Captain James Harrington of HMS Holdfast. He commanded the first ship to lay a pipeline across the channel. It was the most dangerous mission of his career. Slow-moving, vulnerable, a target for every German U-boat and aircraft in the area. But he completed the mission, and then he did it again, and again, laying pipeline after pipeline until the channel was crisscrossed with fuel lines. Harrington was a veteran sailor. He had served in the Royal Navy for 20 years. He had seen action in the Atlantic, in the Mediterranean. But nothing prepared him for the stress of laying pipelines under enemy fire. The ships were slow, defenseless, and loaded with fuel. A single hit could destroy everything. But Harrington never wavered. He followed his orders, laid the pipelines, and brought his crew home safely, every time. After the war, he was awarded the Distinguished Service Order. But he rarely spoke about Pluto. When asked, he would simply say, "We did what we were told to do." And there were the soldiers who guarded the terminals, the anti-aircraft crews who protected the pumping stations, the intelligence officers who kept the operation secret. Every one of them played a part. Every one of them was essential. But perhaps the most remarkable thing about Operation Pluto wasn't the technology. It wasn't the engineering. It was the collaboration, because Pluto required cooperation on a scale rarely seen in war. Military and civilian, British and American, engineers and soldiers, all working toward a common goal, all trusting each other, all believing that the impossible could be done. And it was done. Not by one person, not by one team, but by thousands of people, each doing their part, each contributing to something greater than themselves. That's the real story of Operation Pluto, not the pipelines, but the people who built them, the near disasters. Not everything went smoothly. There were moments when Operation Pluto came perilously close to failure. Moments when a single mistake could have doomed the entire operation. And moments when luck, more than skill, saved the day. One of the closest calls came in July 1944. A pipeline was being laid from Shanklin to Cherbourg. The weather had been calm for days. Perfect conditions. The ship, HMS Latimer, was making good progress. The pipeline was feeding out smoothly. Everything seemed to be going according to plan. Then, without warning, the pipeline snagged. Something on the seabed had caught it. The ship lurched, the drums stopped rotating, and the pipeline, still under tension, began to strain. If it snapped, the entire operation would be lost. Weeks of work, millions of pounds, and the fuel supply to Cherbourg would be cut off. The captain ordered the ship to stop. Engineers rushed to assess the situation. But they couldn't see what had snagged the pipeline. It was 200 feet below the surface, in murky water, with strong currents. Sending a diver down was risky, but there was no other option. Thomas Riley volunteered. He suited up, checked his equipment, and went over the side. The water was cold, dark. He could barely see his hand in front of his face, but he followed the pipeline down, hand over hand, until he reached the snag. It was a rock, a large, jagged rock jutting up from the seabed. The pipeline had wrapped around it, caught in a crevice. Riley tried to free it. But the tension was too great. The pipeline was stuck fast. And every second it remained snagged, the risk of it snapping increased. Riley surfaced, reported what he'd found. The engineers conferred. They had two options: cut the pipeline, lose everything they'd laid so far, and start over, or try to free it, risk snapping the pipeline, but possibly save the operation. They decided to try. The captain ordered the ship to reverse, slowly, carefully, reducing the tension on the pipeline. Riley went back down, this time with a crowbar. He wedged it into the crevice, pried, pushed. The pipeline shifted inch by inch, and finally, it came free. Riley surfaced, gave the signal. The ship moved forward, and the pipeline continued to feed out. The crisis was over, but it had been close, too close. Another near disaster occurred at one of the pumping stations. The pumps at Dungeness were running at full capacity, pushing fuel through multiple pipelines. The strain was immense, and one of the pumps began to overheat. The bearings were failing. If the pump seized, the entire fuel supply would be cut off. Harold Simmons, the pump operator, noticed the problem immediately. The temperature gauge was climbing. The pump was vibrating, making a grinding noise. He knew he had minutes, maybe less, before the pump failed completely. He shut down the pump, grabbed his tools, and began to disassemble it, in the middle of the night, in the dark, with only a flashlight. The bearings were scorched, fused to the shaft. He had to chisel them off, replace them, reassemble the pump, and get it running again before the fuel supply was interrupted. He worked for 3 hours, his hands bleeding, his back aching, but he got the pump running. The fuel started flowing again, and no one on the front lines ever knew how close they had come to running out. There were other close calls, pipelines that developed leaks, ships that were nearly torpedoed, terminals that were bombed, but each time the men and women of Operation Pluto found a way. They improvised, they adapted, they refused to give up, because they knew what was at stake: the war, the lives of thousands of soldiers, the future of Europe. And they weren't going to let a rock or a bearing or a German bomb stop them. That determination, more than any technology, was what made Operation Pluto succeed. Not because everything went perfectly, but because when things went wrong, the people involved refused to accept failure. They found solutions, they took risks, they did whatever it took to keep the fuel flowing. And in the end, that made all the difference. The German response. For months, the Germans didn't understand what was happening. They knew the Allies were advancing. They knew fuel was reaching the front lines. But they assumed it was coming by ship, by truck, by the traditional supply routes. But by late summer of 1944, German intelligence began to suspect something else. Reports came in from U-boat commanders, strange cables on the seabed, unusual activity around certain coastal areas, ships that looked like minesweepers but behaved differently. One U-boat captain, Kapitän Leutnant Werner Schultz, reported finding what he described as a thick cable or pipe on the channel floor. He attempted to damage it with explosives, but the pipe was buried too deep, and the currents made it difficult to place charges accurately. His report was filed, but it was largely ignored because the idea of an undersea fuel pipeline seemed absurd. But as more reports came in, German High Command began to take notice. They ordered reconnaissance flights over the English coast. Aerial photographs were analyzed, and slowly the truth began to emerge. The Allies had built pipelines across the channel, pumping fuel directly into France. The reaction was a mixture of disbelief and alarm. Disbelief because the engineering required seemed impossible. Alarm because if the pipelines were real, they represented a massive strategic advantage, one that the Germans couldn't easily counter. Orders were issued: target the pipelines, destroy the terminals, cut the fuel supply. But it was easier said than done. The pipelines were underwater, invisible, protected by the sea itself, and the terminals were heavily defended. Anti-aircraft guns, barrage balloons, fighter patrols. German bombers attempted raids on the pumping stations, but most were shot down before they reached their targets. U-boats tried to locate and destroy the pipelines, but the channel was heavily patrolled by Allied destroyers, and the pipelines were buried on the seabed. Difficult to find, difficult to damage. One German commando unit was tasked with sabotaging a terminal. They landed by boat on the English coast, but they were captured before they reached their target. The operation was a failure. By the autumn of 1944, the Germans had largely given up. The pipelines were too well protected, too difficult to destroy, and the war was turning against them. Resources were needed elsewhere, on the Eastern Front, in the defense of Germany itself. But the fact that the Allies had built such a system impressed even their enemies. After the war, German officers would describe Operation Pluto as one of the most ingenious logistical achievements of the conflict, a testament to Allied engineering and determination. And they were right. Because while battles are won with bullets and bombs, wars are won with logistics, with supply lines, with fuel, and Operation Pluto ensured that the Allies never ran out, the fuel that won the war. By the end of 1944, Operation Pluto was in full operation. 17 pipelines stretched across the English Channel, from England to France, from the Isle of Wight to Cherbourg, from Dungeness to Boulogne. Together they pumped over 1 million gallons of fuel per day, enough to supply entire armies. The impact was immediate. Tanks that would have been stranded for lack of fuel kept moving. Trucks that would have been grounded kept rolling. Aircraft that would have been unable to fly kept taking off. The Allied advance, which could have stalled, continued relentlessly. General George S. Patton's Third Army, racing across France, depended heavily on Pluto fuel. Patton was famous for his aggressive tactics, his rapid advances. But those advances required fuel, massive amounts of it, and Pluto delivered, day after day, week after week. The same was true for the British Second Army. for the Canadian First Army, for the American First Army. All of them depended on the fuel flowing through those invisible pipelines, and all of them advanced faster, farther than would have been possible otherwise. By the spring of 1945, the Allies were deep inside Germany. The war was nearly over, and Operation Pluto had delivered over 180 million gallons of fuel, enough to fill 720 Olympic-sized swimming pools, enough to power an entire nation's military for months. But the true measure of Pluto's success wasn't in gallons. It was in lives saved. Because every gallon of fuel delivered by pipeline was a gallon that didn't have to be shipped by sea. And every ship that didn't have to cross the channel was a ship that couldn't be sunk by a U-boat, couldn't be bombed by the Luftwaffe, couldn't be lost in a storm. Estimates suggest that Operation Pluto saved thousands of lives. Sailors who would have died on supply ships, soldiers who would have been stranded without fuel, pilots who would have been grounded. All of them lived because of a pipeline no one believed could be built, and the economic impact was equally significant. Shipping fuel by sea was expensive, dangerous, inefficient. Pluto was cheaper, safer, more reliable. It freed up ships for other uses, transporting troops, carrying equipment, delivering supplies. The entire Allied logistics network became more efficient because of Pluto. After the war, military analysts studied Operation Pluto extensively. They concluded that it was one of the most important logistical achievements of World War II, on par with the Mulberry Harbors, with the Red Ball Express, with the airlift over the Himalayas. It was a game changer, a force multiplier, a silent weapon that won battles without firing a shot. And yet, for decades, it remained largely unknown, classified, secret. Because even after the war, the technology was considered sensitive. The techniques developed for Pluto were used in other projects: undersea cables, oil pipelines, infrastructure projects around the world. The lessons learned in the Channel were applied globally. But the men and women who built Pluto never sought recognition. They had done their job, solved an impossible problem, and moved on with their lives. It wasn't until the 1990s, when documents were declassified, that the full story of Operation Pluto began to emerge. And even then, it remained a footnote in most histories of the war. But for those who know the story, Operation Pluto stands as a testament to human ingenuity, to determination, to the belief that no problem is too big, no challenge too great, that with enough creativity, enough effort, enough courage, the impossible can become possible. Because in the end, wars aren't won by the biggest armies or the most powerful weapons. They're won by the people who solve the problems no one else can solve, who build the things no one else believes can be built, who refuse to accept that something can't be done. And in 1944, a group of engineers, sailors, and workers did exactly that. They built a pipeline under the ocean. They pumped fuel across the English Channel. And they helped win the war, the legacy of the impossible. When the war ended in May 1945, Operation Pluto didn't stop immediately. The pipelines continued to pump fuel for months, supporting the occupation forces in Germany, supplying the reconstruction efforts in France. It wasn't until late 1945 that the pumps were finally shut down, and the pipelines were decommissioned. Some of the pipelines were recovered. Pulled up from the seabed, the lead was recycled, the steel reused. But many were left in place, too difficult to recover, too expensive to salvage, and so they remain. Even today, buried on the floor of the English Channel, silent, forgotten. but still there. The pumping stations were dismantled, the terminals torn down. The ships returned to civilian service. Within a year, almost all physical evidence of Operation Pluto had disappeared, as if it had never existed. But the legacy remained. The technology developed for Pluto revolutionized pipeline engineering. The flexible lead pipes, the protective coatings, the laying mechanisms, all of them were adapted for peacetime use. Undersea oil pipelines, transatlantic cables, infrastructure projects around the world. The techniques pioneered in the Channel became standard practice, and the lessons learned went beyond engineering. Operation Pluto demonstrated the importance of logistics in modern warfare. It showed that wars are won not just on the battlefield, but in the supply lines, in the factories, in the planning rooms. It proved that innovation and creativity are as important as firepower and manpower. Military academies around the world now teach Operation Pluto as a case study. In logistics, in engineering, in strategic planning. It's held up as an example of what can be achieved when people work together toward a common goal, when they refuse to accept limitations, when they dare to attempt the impossible. But perhaps the most important legacy of Operation Pluto is the reminder that history is made by ordinary people, not just generals and politicians, but engineers and welders, sailors and pump operators, people who never sought glory, who never expected recognition, who simply did their jobs, and in doing so, changed the world. Arthur Hartley, the engineer who first proposed the idea, returned to civilian life after the war. He continued to work in the petroleum industry, designing pipelines, solving problems. He rarely spoke about Pluto. When asked, he would simply say, "We did what needed to be done." He died in 1972, quietly, without fanfare. But his contribution to the war effort was immeasurable. Bernard Ellis, who designed the flexible pipeline, went on to work on major infrastructure projects around the world, including the first undersea oil pipeline in the North Sea. He credited his work on Pluto as the foundation for everything that came after. "We learned that nothing is impossible," he once said. "You just have to be willing to try." Jeffrey Lloyd, the chemist who developed the protective coatings, continued his research after the war. He made significant contributions to materials science, and he mentored a generation of young engineers, teaching them the same lesson he learned during Pluto. Don't accept that something can't be done. Find a way to do it. And the sailors, the divers, the pump operators, the welders, most of them returned to their pre-war lives. They raised families, built careers, lived ordinary lives. But they carried with them the knowledge that they had been part of something extraordinary, something that mattered, something that made a difference. Today, there are memorials to Operation Pluto, small plaques in Dungeness and Shanklin, a museum exhibit in Portsmouth, but they're easy to miss, tucked away, unassuming, much like the operation itself. But for those who take the time to learn the story, Operation Pluto stands as one of the great achievements of World War II, a triumph of engineering, of determination, of human ingenuity. It's a reminder that the greatest victories are often the ones no one sees, the ones that happen in the background, the ones that make everything else possible. Because while soldiers fought on the beaches, while pilots flew in the skies, while generals planned in the war rooms, a pipeline pumped fuel beneath the waves, silently, invisibly, relentlessly, and that pipeline, more than any single battle, helped win the war. The men who laughed at the idea, the engineers who said it couldn't be done, they were wrong. Because it was done. Not easily. Not quickly. But it was done. And the world was changed because of it. That's the lesson of Operation Pluto. That the impossible is only impossible until someone does it. That the greatest achievements often come from the most unlikely places. And that sometimes the most important battles are fought not with guns and bombs, but with wrenches and welding torches, with pipelines and pumps, with determination and belief. In the end, Operation Pluto wasn't just about fuel. It was about possibility, about refusing to accept limitations, about daring to dream big, and about the ordinary people who made those dreams reality. The pipeline under the ocean, the fuel that won the war, the impossible that became possible. That's Operation Pluto. And that's a story worth remembering. What surprised you most about this story? Share your thoughts below. And remember, the next time someone tells you something can't be done, think of the engineers who built a pipeline under the English Channel, in the middle of a war, against all odds. Because if they could do that, what can't we do?